Okay, welcome back. We discussed about no relationship, regular referenced, and fact in last session. So we've given, I told you like this is inner join, and if you have one more inner join, like two inner joins to join the fact table and the dimension table, that is referenced. And if it is only in one inner join, that is regular. And if the dimension table and the fact table are same, then we call it as fact relationship. Before going to the many-to-many relationship, I would like to explain about one concept, database concept, how two table data is related. Okay, data will be related in these ways. One is one-to-one. Okay, that means if you take one table, if you take another two tables, one row, let's say ID employee ID 1, okay, will have only one record in the second table. That is one-to-one. In the same way, employee ID 2 will have only one record. Employee ID 3 will have only one matching record. Okay. So this kind of relationship is called as one-to-one relationship. Typically people use it while storing employee information. Let's say this is your employee table. You will have some 10 to 20 columns like employee ID, name, designation, department, manager, blah, blah, blah. And all the junk columns are, not important columns. They will move it into additional information. The additional information will be moved to a different table. Let's say this is employee table, and this one we call it as employee additional details. Employee underscore additional details, where they will have all the junk data like address 1, address 2, address 3, address 4, city, state, PIN, all the information that is not of high priority. In this case, one employee here, one employee ID here should have only one record in this table, right? One employee will have only one address related information. So this kind of relationship is called one-to-one relationship. Okay. If you have something like this, what you will do? You will use regular relationship and join these two in SSAS cubes. The other type of relationship is one-to-many. One, two, three. The same guy in the first table will have many relationship, many child records. Let me explain you this. Let's say this is your table, product Liril soap. Okay, Liril is the product name of the first record. This Liril soap will not be taken by only one customer, right? So many customers might have purchased the same Liril soap. Let's say this is the first customer who bought it, and one more customer, and one more customer, and one more customer. So one product in the master table will have more than one records in the fact table or transaction table. Okay. This kind of relationships is called one-to-many relationship. That how the data is related. Data is related in one-to-many fashion. There may be only one record, or there will be only one record here. There may be 0 to n number of records in the transaction table. Even this one, this will become regular relationship. And if you have something here, let me hide it. And if you have one more table in the same way or in any other fashion, then these two will become referenced. So we discussed about one-to-one and one-to-many. The final one is many-to-many. This case is different. This is your master table and this is your another table. One guy will have many records from here. Okay. And this guy again having relationship to many here. I will explain you in an Excel. See, the simple logic is one record here will have many records. In the same way, one record here will have many records. So let me explain all these things in an Excel. If we are lucky enough, let me see whether we have Excel or not. Nope, we don't have Excel here. Let me do one thing. Let me take a notepad. Let's say book ID is the example and book name. book ID by Rupesh is book ID is 1, author is Rupesh. Book ID is 2, author is Lokesh. Book ID is 3, author is Vinay. Let's say this is your master information. Okay. We're going for book names, right? So let me name it as C. This is C++, and third one is Java. In the transaction table, I'll have like this: book ID and say amount. Here book ID 1 will be there, sold for $100. Again book ID 1 by some other customer for $100. Again 1 for $100. So this kind of relationship is called as one to many. You can see this ID is here. Only one time is used many times in the transaction table. So this kind of relationship is called as one to many relationship. Okay. Now let's see how to design. What is the scenario where the many to many will come into picture. Take any two books. Let's say one is C, another one is C++, and another one is Java. Okay, these three books. C, the book is written by many authors, and many authors. A book is written by many authors, and one author has written many books. Can you understand? Let's say this is your table 1 and table 2. This is book 1, book 2 and book 3, author 1, author 2 and author 3. Okay, 3 rows means 3 records. This book is written by this guy and this book is written by this guy also. So this book has one to many here, to table 1 to table 2. Now this book is written by this guy and also by this guy. Assume that. And the third book, this book is written by this guy and also this guy. Now if you see from here to here, it is one to many. This record is having 2 child records. First one is 1 and the next one is 3. In the same way, this record is having 2, this record is having 2. In the same way, if you see from here, this record is having 2, 1 and 2. This record is having 2, 1 is here and 1 is here. This record is having 2, 1 is here and 1 is here. So both sides, anyway, if you see, it will be one to many, and overall we call it as many to many relationship. A book is written by many authors. One author has written many books. So this is called many to many relationships in SQL Server and also in SSAs. How to give relationships if you have data like this? If you have data like this, how to give many to many relationship in SSAs? Let's see that one now. Now let's see by creating tables for many to many relationship. Let's take the same example, authors and books. So I'm gonna create couple of tables here. First table is authors. This table has only 2 records. One is ID, integer, and another one is author name, varchar of 100. Okay, I'm executing this table. Table with the name authors is created. Now I'm gonna create books. ID is int again, book ID, and book name is varchar. I created another table. You can see it completed, command completed successfully. So I created 2 tables. One is authors and another one is books. Now I have to set the relay. What is my fact table where I am gonna have the sales information? I'm gonna have the sales information in let's say sales. Here I'm gonna maintain book ID and sales amount. I'll take money data type. Okay, I've created three tables. One is authors, another one is books, and third one is sales. How these three are related now? These three, based on the IDs, you can understand. This is your authors, the first one, which has only ID and ID and name. This is your books, which has book ID and book name. This is your sales, which is having book ID and amount. So these two are related. This book ID and this book ID will be joined, right? How these two are related? These two are not related now. This is author ID and this is book ID. I cannot keep author ID here. The problem is the rows will get duplicated. Why? Because the book ID 1 will be, let's say, C, written by author 1. Again 1, again C, the same book is written by author 2. So if I follow this rule, if I try to store the data like this, I will get duplicates into my primary key column. Right? This is not the correct way of designing the database. If I get duplicates into the primary key column, I cannot define it as primary key. If I don't define it as primary key, I cannot use this as foreign key with this, right? So this is the problem. I cannot have this book ID here when I have many-to-many relationship. The way that we can give relationship between these two is by adding an intermediate table like this. This table will have only author ID and book ID. Let's say author ID 1, he has written book 1. Author ID 1, he has written book 2. Author ID 2 has written book 2. Author ID 3 has written book 2. Okay. Again author ID 2 and 3. Let's say this guy has written 3. This guy has written 3 and 1. You can see this is how you can relate many to many. From here you can give relationship to this, and from here it will go to this, and from here it will come to the fact. I'm injecting one extra table in the middle. This table we call as bridge table in SQL Server concepts and factless fact table in SSAS concepts. Okay, I will explain you about factless fact table more. So this is one example. The another classic example from cricket. If you take the game cricket, here you will have player 1, let's say Sachin. Here you will have team 1, let's say India. And again team 2, this is Mumbai Indians. He also play for Mumbai Indians, right? So what I'm gonna do here, in this bridge table, player ID 1, he plays for team 1, that is India. Player ID 1, that is Sachin, he plays for team 2, that is Mumbai Indians. So whenever you have many to many relationships, then you have to go for a bridge table in the middle to have a proper relationship between the data. Now I have done the same. I created one authors table, one books table, and one sales table. The next job that I have to do is to accommodate the data of many to many relation, how these two are related, the books and the authors. I'm going to do the same by creating a bridge table now. So I'll call the bridge table as auth books. Here I'll have book ID and author ID. That means author ID. So let me execute this. Now all the 4 tables are ready. Now my job is to insert the data. Insert into authors values 1 comma one author name is, let's say, Rupesh, and I'm inserting one more author, that is 2 Lokesh, and 3, this is, let's say, Vinay. Now what I have to do here is I have to enter the data for books. Let me copy the same insert statements. Instead of repeating it again and again, we can go for the same. 1, 2. Let's say the first book name is C, second book name is C++, and the third one is Java. And the third table is sales information. Let's add some information to the sales. Before going to the sales, let's go for auth books. So let me insert some valid data into auth books table. So author ID 1, he has written book 1. Author ID 1 has written book 2. Author ID 2 has written book 2, and author ID 2 has written book 3. I'm giving 2 books per guy, and 1 book is written by 2. So this is 3 and this is 1. This is also fine. Now let's go for sales table. So I'm gonna have sales for all the books. I'm gonna have book ID here, right? So I'll give sales, 2 sales records for each book. This one is $100. Let's say this is $200. This is $300. Again, book 1 got sold, that is $100. This is 200, 300 and 100. Now I have good enough information that is required for my analysis path. So let me select all the tables once. Select star from authors, books, the third one is auth books, and fourth one is sales. So if I execute this, let me expand this here. If I ask for which book has what sales, then what it will do, these two has direct relationship, right? The sales table and the book table. So it will take, for example, if I ask for a C book name C, it will take the ID 1, it will come here, it will check, okay, $100 plus $200, that is $300 is the sales for the book C. So C++, it will come here, $200 and $300, that is $500. For Java, it will come and it is 300 plus 100, that is $400. It will give information like this. Now, if I ask the same for author Rupesh, okay, for example Rupesh, it will come here, Rupesh author ID 1, it will come here, it will take this ID and also this ID. Here author ID is 1, here author ID is 1. This guy has written 2 books, one is book ID 1 and another one is book ID 3. So it will take the book ID 1 here and get the information. You have 2 records. One is the first one and the other one is the fourth one. It also gets the 3 ID, book ID 3 and take the sales. So a total of 100 plus 300, 400 plus 200, 600 plus 100, it will be 700 as the output. So the value, this is how the sales will be taken from the fact table when there is a many-to-many relationship between 2 tables. Now let's add these 4 tables and try to create the or try to implement the many-to-many relationship in our SSAS cube. Yeah, you may get doubt like how you will set the many-to-many relationship to the last 2 tables. Sorry, primary key for the last 2 tables. First thing, this is a fact table. Fact table does not require a primary key. So we won't set any primary key for this. And second thing, this is factless fact table. We call it as in SSIS or bridge table. Even this one, we don't need primary key. We will set primary key only for the dimension tables, this one and this one. I will show you this one when we work on SSA. When we implement the same in SSIS now. So for that, let me go to BI solution and let me go to AdventureWorks. What I'm gonna do here is I'm gonna take a new page. Okay. I'll take a new diagram. Okay. New diagram is nothing but this one. You can have some set of tables. You can categorize some set of tables. It will be easy for you to search. If I add those tables into this set, it will be very clumsy. So a new diagram, I'll name it as many to many example. In this one, I can add the tables. One is authors, books, authbooks, and the next one is sales. So I've taken all these four. You can see all the four here, and this is the main one where you will have all the tables. Let it be here, but for us to understand better, I categorized in a special diagram by selecting the option new diagram here. Okay. Now I'm gonna give relationships here. This is my fact table, right? This one is having relationship to book ID. It is saying there is no primary key for define. Would you like to define? Yes, define it. Primary key is define. Now this book ID is having relationship with this book ID, right? And this author ID is having relationship with this author ID, and again it is asking there is no relationship. Primary key, would you like to set? Yes, I like to. And now let me arrange the tables. You can see this is your main and last table. This is the next, this is the dimension table which is having direct relationship, and this is your fact table. This is your dimension table which is having indirect relationship to the fact through two tables, not one table. Earlier reference type, it was only one table. Here you have two tables. One is factless fact and one other one is dimension. So what is the first step we have to do to implement the factless fact, many to many relationship here? The first thing is creating the dimensions for the books and the authors. So let me go here, go for authors, click the name, and done. The next job is adding creating a dimension for books. I'm selected the books. I'll do one thing here. Both will be the name, so I will rename it as books, and I will rename this author's name as authors. Okay, fine. The first job is done, and the next job is I have to add that stuff into the cube. So I've added these two dimensions here. Now it is set. For these sales, we cannot set that information. Why? Because this is not related. This is entirely new tables we added. What is the fact table here for us? The fact table here for us is a sales table again. Okay, it's already present, so it is saying the name as sales 1. Better I show it as book sales. Okay. Now this book sales has direct relationship with the books table, so it has set as a regular relationship. When the fact and the dimension are directly related, we call it as regular relationship, and it has taken the ID and the ID, and in the measure group table it is book ID. This is set. Now how to set the authors? There is no relationship we can give here for the authors. Authors are not directly related. We need the factless fact table here. The table what we created as bridge here, we need it in the SSAS. So what we will do with the table is we will make it as a fact table. If you see here, we'll make the auth books as fact table. You will not have any measures here, just one count measure. Apart from that, nothing. So this is a fact table, but without having any facts. If you see here, the amount is a fact or measure, which will give some metric information. In sales, you have sales and tax amount, which will give some metric information. But this one is empty. It does not have any facts. Don't consider this count as a fact. That is the default and dummy one what will be created, which will be created when you add any measure group. Okay. So this is called as factless fact table. Why? Because this is a fact table. You can see whatever that is present in these measures, it is a fact table, but it will not have any facts. So, and factless fact table. This factless fact table, by default, it is related to authors and it is related to books. Why? Because these guys are related, right? You can see it. This ID to these authors and this ID to this. Now, we are set. Remember one point, whenever you are giving relationship, fact relations, many-to-many relationship, it should be like this. You will have two dimensions and one measure group and one factless fact measure group. This factless fact will have direct relationship with these two, and at least one, either this or this, should have direct relationship with the fact table. The other one, the one which is pending, will be considered as many-to-many. Okay. Here you have to specify what is the intermediate measure group. That's it. The intermediate measure group is, we know that is auth books. Now, if I ask for authors wise book sales, how it will happen is it will come here, and from here it will go to this, it will go here, it will come here, and then it will get the books sales. So this is how the many-to-many relationship works. So that is how it flows. If you see from author, if you want to get books wise sales, it will come here directly. It will join with this table and get the data. But that's not the case with authors. Authors will come here. It will go to the author IDs. It will auth books table. It will get the IDs and it will get the matching IDs of books. It will come here and then it will get the sales information of the authors. Now, if you process this, you can see how the data looks. After giving these many-to-many relationships. So I'm reconnecting it and erasing it. So book sales, the total amount is 1200. And if I select books, it is pretty straightforward one. It will get 300, 500, 400. Okay. Now if I remove this, if I get authors, this is the total book sales. But author wise, if you see, it will be more. 9 plus 7 plus 8 is not 1200. The 1200 is total book sales. But in this guy's quota is 800. This guy's quota is 700. This guy's quota is 900. If you want to make it more clear, drag and drop books here. C is written by this guy and this guy. Each guy will get 300 as per the sales if you see. And C++, location Vinay has written this and the book cost is 500. And 2 books were sold, right? Or 1 book, whatever it may be. So Java written by Rupesh and Vinay and it is 400 and 400. So this is how you can evaluate the values. When the data is having many-to-many relationships. And this is fantastic one, to be frank. If you see this dimension usage, we discussed about 5 different relationship types till now. It covers almost all kinds of scenarios that you have. What are all the different scenarios you can expect? The first scenario is same table joining. Fine, it is done with fact relationship. The second scenario is no relationship between these two tables. Fine, set. The third scenario is direct relationship. Set. Fourth one is indirect relationship. That is also set by having dimension in the middle. Now the fifth scenario is many to many. That is having bridge table in the middle. We are able to set the relationship. So this is the heart of SSIS cubes. If this is not proper and if this is not set, then that means that is not a cube. You cannot make even a 1% use with the cube. For example, if you see this authors and this sales is not related. Why? Because there is no relationship between these two guys, right? Now, if I remove this amount and if I take the sales amount from the measure group which is not having relationship, you can see all junk data, right? So that is why this relationship plays a major role in SSIS cube development. This is about many to many. I mean, good, you understood the concepts. Now let's go back and while adding a measure, okay, for example, for sales amount and tax amount, what we have done, we have taken sum of sales amount and sum of tax amount. We can have different functions here. You can see different usage. You can take the count of rows. If you take count of rows, then you don't need to specify any column. Why? Because count of a particular column is equal to count of all the columns, right? Count of star is equal to count of 1. So if you select OK, this one will give you sales count, how many rows are there. It won't give you the amount you have, okay? It will give you the number of rows it is having per product or per what we can subcategory or per category. Let me show you that example. So if you come here, now the sales amount, this is giving amount, the sales measure. I'm taking count now. This count is giving 6398. What is this? This is the number of rows that are present in the table. If I take product color wise, it will give you how many rows are there per color in the fact table. For this color in the product table, this many records are there in the fact table. So this is how you can specify different measures, different usage for the measures, like I specified count here and sum here. Like that, you have so many things, and recently added things are there. I mean, in latest versions they added even more. If you see count of non-empty values, this one will give you the list of rows that are present without having null value. Okay, if you take that, then you can select a column, like let's say unit price. If unit price has the total number of rows is 60,398 or something, I have shown you now. Now if this unit price is having null values for 3 records, the output of this one will be 60,938 minus 3. Why? Because 3 are nulls. And this one will give you the maximum value of any particular column. If the unit price, what is the maximum unit price and what is the minimum unit price, you can calculate that. And this is the maximum, this is the minimum, and this is distinct count. It will give distinct counts and no aggregations, means as is it will show. Account, it's a new one added, average over time. I mean, these are newly added. Even I have never tried that. I have to see that. First value and last value will give the first value that is present in the transaction table, and last value will give the last value that is present for this particular transaction. And first non-empty value and last non-empty value is same like count of non-empty rows. It will try to get the first non-empty value. If the first record is null, then it will exclude that and it will get the second value if it is having non-empty value. Okay, this is the different possibilities, but most of the cases you will go for sum, very few cases count of rows, and very few cases first value and last value and minimum value and maximum value, and distinct count hardly. You're not going to use the remaining things, and it's again depends on your requirements. If the requirement comes like, okay, give me non-empty count of non-empty values, then you have to go for that usage. And this is how you can update it. That's what I mean. This is how you can create it. That's what I'm trying to explain you here. This is the place where you can select what they want to implement. what they want us to implement. Okay. So we discussed about a lot of concepts today, like in last session we discussed about different relationship types except many-to-many. In this we discussed about many-to-many and how to add measures, measures with different functionality or different usage, I can call it as. Now let's see a concept today. Okay. If you see, we created so many dimensions, right? This is a dimension. If you go to the properties of the dimension here, you can see one property, that is storage mode. Okay. This storage mode, you had only two options, molap and rolap, and this in memory is recently added in 2008 R2. Okay. Let me explain you. There are three storage modes. And what is storage modes? Let's have a discussion on storage modes before signing off for the day. Okay. What storage modes will say is how you want to store the data, how you want SSIS server to store the data. You have to specify that. Okay. As I told you in earlier sessions, this is your OLTP database. Okay. And this is your cube solution, and this is your analysis service database. What this cube solution will do is whenever you process it, it will read the data from here. And after reading the data, it will do three things. One is place the data somewhere and create aggregations on the data and create indexes on the data. Okay. This is the three steps what it will do when you process the cube. Now, where it has to place, this is the topic, storage modes. Storage mode will tell the server about where the data to be stored, which is being pulled by the SSIS solution. We have three types mainly. First one is molap, which is the default one, I can say. Second one is everything is same, but the first character is rolap, and the third one is holap. Okay. So this molap, let's go one by one with its advantages and disadvantages later. First, what is molap storage mode? Molap storage mode, what it will do is whenever you select it as molap, okay, as you're seeing here, if you select any dimension or any measure group as molap, then it will get the data from a relational database and it will place the data, it will copy the data to analysis service files, and it will create the aggregations here and indexes here. It will create aggregations and indexes in the analysis service side. So everything will be on analysis server. Okay. That means from next time onwards, the front end, if you write MDX or any SSRS application, will be getting data from analysis server. So this is molap. The storage part will be on analysis services. What it is going to store? It is going to store the data as well as aggregations and indexes. Now let's go to the rollup. What rollup will do is it won't do anything to the data. It will keep the data here only in the OLTP database as is. Whatever the data that is present as is, and apart from that it will create aggregations and indexes in the same relational database. Okay. So if this guy SSRS report asks for some data from this analysis services, it will come here with MDX query. It will generate a relevant SQL query here, and this SQL query will be queried here, and it will return some result to this, and this result will be given to the report. You can easily understand the performance with this one is performance. So the problem with this one is performance. So in short, rollup will store all the data as well as aggregations and indexes in the relational database. It is not going to store that information in analysis services. And the third one is hybrid. Hybrid, as the name says, it is hybrid. The data will be here in OLTP, and aggregations and indexes will be created in the OLAP database. It's a mixture of these two. So in simple, we have three storage modes are useful to store the data, which will help us in retrieving when the data for the applications faster. So there are three types of storage modes. One is MOLAP, another one is ROLAP, and the third one is HOLAP. MOLAP storage mode will store the data as well as aggregations and indexes in the analysis server, whereas ROLAP keeps the data as is in the relational database and creates the aggregations in the same database and also indexes in the same database, whereas HOLAP, it leaves the data as is in the relational database and it creates the aggregations and indexes in the analysis services. Now let's see the difference, advantages and disadvantages of each one. First, let's start with the advantages of each one. Let me take this is application and this is, first let me go for MOLAP. Everything will be here, right? So the first advantage is it is super fast. Performance wise, super fast. There is nothing else in all the three storage modes which can beat the performance of this MOLAP. Okay, that's the only advantage you have, MOLAP. The second one, ROLAP, its advantage is as the data is present here always, right? Try to understand this one. This is concentrate, very tricky. So for ROLAP, the data will be present here and the aggregations and everything will be created in the OLTP database. When I request for data, while requesting, after processing, before requesting, if I add a couple of records to this OLTP database, let's say I added some records into this OLTP database, it will come here, it will go ask for the data. So what will happen is, whatever the data, whatever the records that I add to the database will be immediately available for the reporting services or any report. So it don't need to process again. If I add data here, it will go query and get the data. That's the advantage. In short, this one will provide real-time cases, real-time scenario. Okay. The hybrid one, the HOLAP, the advantage is it is super fast, like MOLAP storage mode, only when you are querying aggregated data, that is high level data. Okay. Now let me explain the disadvantages plus advantages. First, MOLAP. MOLAP is super fast. Why? Because while processing, it gets all the data and paste it here and create the aggregations here. So it is super fast. The disadvantage is, if I add new record into this, then I have to process again to get into this one, right? And if I add one more record, I have to process again to get the same data into this. So in other words, this MOLAP database, MOLAP storage mode is always outdated. If I process the cube today, and when I have 1 lakh records in my database, if I process the cube, all those 1 lakh records will be pushed into analysis server using MOLAP storage mode. And if I come after 20 million years, the same 1 lakh records data will be available in the analysis server until and unless I process it again. If I process it again, then all the fresh data will come into this cube. So the disadvantage is it is not real time. The advantage is it is super fast. Now let's go to the ROLAP, relational online transaction processing. As the data is getting from this, as the data and the aggregations are created at this level, the major disadvantage is performance. The performance is not as good as HOLAP. And the advantage is, if I add one record, that will be immediately available for SSRS reports. So the major disadvantage is performance. And the third one, HOLAP, It is super good when you are aggregating when you are pulling high level data, that is aggregated data, and it is super slow when you are pulling leaf level data, the data at the least level. Aggregated means group by statements. When you implement group by statements, you will get some aggregated data, right? So that is aggregated data. Whereas leaf data means as is select star from employee or select star from fact internet sales. That is leaf level data. For leaf level data, it goes to this. That's why it is slow. For aggregated data, it goes to high level data. It goes to aggregations part. So it is super fast. So this is about the 3 different storage modes available for us. Up to SQL Server 2008, it accepts only 2 types for dimensions. Okay, one is whole app and another one, sorry, mole app and roll app. Whereas for cubes, or that is for measure groups, it accepts all the 3. Either you can set whole app, or you can set roll app, or you can set mole app. But as per my experience, 95% of the projects will use mole app storage mode. That is the default one set by Microsoft. Why? Because always people want the performance on high priority. They want the performance to be good than the real-time data and all. And 4.99% people or 5% people uses roll app storage mode, and whole app I've never seen people using that. Okay, it is not advantageous in any way, except if you want to get high aggregated data super fast and the other data super slow. So this is about the different storage modes and where you can set the storage modes. You can set the storage modes here. For dimensions, there is a property called storage mode. You can set it here, and in memory I'm yet to see that what is that in memory. I think the built-in memory will be available to store the data of this particular dimension. For measure groups, for measure groups, you cannot set it here. If you go to the properties, you will not find the here it is. You can set the mole app or whole app or roll app or in memory. You can also set the storage mode in the partitions. For every measure group, you can see one partition. How many measure groups we created till now? We created 3. One is sales and another one is book sales. This is factless fact table, that is art books. So for everything, you can set the storage mode here, storage settings. Okay, this is mole app and this is whole app. Here it is the whole app and this is roll app. You can see low latency and mole app and medium latency. Mole app are the different options that are available in the mole app based on, you can see here, processing is performed automatically with a target latency of 4 hours. In the same way, this is no restriction on latency and this one is 4 hours latency again. So storage mode wise, if you wish to select, if you wish to go for whole app or mole app, come to the fact table definition and go to the properties and set the storage mode whatever you want. But keep in mind, roll app will degrade the performance like anything. Peak, it will degrade the performance like it will become damn worse. It's like acquiring SQL Server database. SSAS will come into picture only when the performance problem is there to query the data, inquiring the data from databases. In being that having that case, if your cube is also poor in performance, then it is of no use. Injecting this particular module is of no use. So that is why people prefer to go with mole app storage mode. Okay, this is about storage modes, and in next sessions we are going to discuss about many other tabs we have that are available in the cube solution. We discussed about only cube structure, dimension usage and browser. In this we have calculations, KPIs, actions, partitions, aggregations, perspectives and translations. You might have seen these translations while discussing about dimensions. This is a little bit different. You can give translations to high level here until cube, measure groups, measures and all. And this perspectives is a very good, simple concept. And The next important thing you have to concentrate on is first one is partitions, and calculations is the next high priority one. So for calculations, KPIs and actions, you need to know MDX part. MDX is nothing but the querying language to query SSAS cube data, just like SQL Server we use, right, to query the data from the SQL Server. In the same way, we use MDX to query the data from cube database. So if you're good in MDX, then you can play with the calculations, KPIs and actions. So we'll explore each and everything in coming sessions. Okay, that's it for the day, and have a nice day.